of this telescope, of this remarkable instrument we put in space, is finding things that we didn't expect, that we can't explain, because that means that we have to revise our understanding of the universe.
Will the history of astronomy be divided between before Webb and after Webb?
Yes, I believe it will be.
So something real is happening, but we can't tell yet if it's a mistake in our observations, a mistake in our interpretation, or just something nature is surprising us with, such as a new kind of dark matter, a new kind of dark energy, or something else that would be really exciting to discover. So if there's a Nobel Prize in here, that could be one of them.
Look at this image. What you see here is a very distant cosmic structure shining brightly in the early universe. But the discovery of this bright object has solved a long-standing mystery of astronomy. Because our current understanding of the universe says that our universe came into existence about 14 billion years ago, and after the Big Bang, the universe went through a period of complete darkness called the Dark Ages. This was the time when the universe was filled with clouds of gas everywhere. Even if we built the most powerful telescope ever built, we wouldn't be able to see beyond the Dark Ages. But for decades, scientists have been noticing that some strange light was coming from the dark clouds. A serious discovery has sparked debate among astronomers recently. For the first time, the Webb telescope observed two ancient galaxies. Intriguingly, these galaxies seem distinct from those familiar to us, prompting questions about their origin within our universe. Such discoveries of the Webb telescope have raised some big questions. Are we wrong about the age of our universe, or are we wrong about the origin of these galaxies? So, what are these strange lights and where do they come from? Well, new discoveries from the Webb telescope have finally solved this mystery and conclude that what we previously thought about the early universe may need to be revised. This new image from the Webb telescope shows that this light is actually a rich source of Lyman alpha emission. This image shows that there were more galactic mergers in the early universe than we were able to see before the Webb telescope became operational. These mergers and interactions, and the abundant star formation they produced, are both responsible for producing Lyman alpha emissions. But scientists previously believed that these emissions should have been blocked by the dense hydrogen clouds that filled the space between galaxies during the Dark Ages, and we should not have seen them. But we see them. Well, researchers have recently shown that as stellar mass gathered and stars formed in these early galaxies, two things happened. The stars gave off Lyman alpha emissions, and they created bubbles and channels of ionized hydrogen in the light-blocking neutral hydrogen gas. The bubbles and channels allowed the Lyman alpha emissions to pass through. So this shows that the stars could detect objects beyond the Dark Ages. And surprisingly, in another recent deep field image, scientists found two galaxies that existed beyond the darkness of the early universe. And scientists are now saying that these galaxies are not like the ones we have seen. On the other hand, both of these galaxies are highly redshifted, and astronomers claim that this would be a serious problem if these objects were indeed galaxies. This graphical representation provides a comprehensive view of distant galaxies as seen through the remarkable capabilities of the Webb telescope. Here we can see the most distant galaxies confirmed by spectroscopic observations. One of them, called GNZ11, is about 13.2 billion light-years away and was first discovered by the Hubble telescope. A recent image from the Webb telescope has revealed something extraordinary in this galaxy. Astronomers have identified a supermassive black hole at its center. This discovery establishes it as the most distant black hole on record, formed just 400 million years after the Big Bang, and challenges our understanding of black hole formation because of its enormous size. Scientists say that the size of this supermassive black hole does not fit the timescale of the universe because the death of the first stars or the merging of black holes in the early universe could not have created a black hole this large. We need a whole new way of thinking about the formation of these massive black holes so early in the universe. But wait, there is something else in this data that has shocked astronomers around the world. Well, as you can see, these are the most distant galaxies discovered by the Webb telescope, and the red tags indicate that these galaxies have already been confirmed by spectroscopic observations. For example, the most distant galaxy currently confirmed is called GZ13, which is about 13.47% distant. Cosmological models say that galaxies first formed at the end of the Dark Ages, but here we can see massive and strange galaxies that existed beyond the Dark Ages. This discovery shows that galaxies formed much earlier than our theories predicted. The problem is, how do we explain the existence of these galaxies? One possibility is that our universe is much older than we thought, or that something strange happened after the Big Bang that accelerated the formation of early galaxies. Well, spectroscopic observations of these two galaxies have yet to be made, but if spectroscopic observations confirm their predicted redshifts, the very foundations of cosmology will be shaken. Now, there is another hypothesis that has recently become popular among scientists, known as conformal cyclic cosmology. This cyclic model of the universe could explain the existence of these strange early galaxies. Nobel laureate Dr. Roger Penrose says that there was a universe before us, which he calls the previous eon, and that black holes evaporated at the end of the previous eon, as predicted by Stephen Hawking. And the evaporated energy from that black hole gives birth to the Big Bang of the next eon. He also postulates that dead black holes from the past universe accelerated the expansion of our early universe. Scientists believe that these dead black holes from the past universe could explain the existence of supermassive black holes and huge early galaxies in the early universe. Well, everything the Webb telescope has discovered so far is challenging our understanding of the universe. It's no surprise that in just 3 years of science, JWST has already broken a number of cosmic records, including records for the most distant galaxy, the most distant protocluster of galaxies, the most distant black hole, the most distant red supergiant star, the most distant gravitational lens, and the most distant quasar. These results suggest that our universe may be much older than originally thought. Alternatively, it could be part of a chain of interconnected universes, or it could have always existed without a definite starting point. Given the seemingly infinite size of our universe, the idea that its age is infinite becomes plausible. The conventional concept of the Big Bang may be just a particular moment in the ongoing evolution of this ever-present causal set, rather than a true beginning. Finally, when you've finished watching this video, don't forget to comment on what you think about these discoveries and what you think about the age of our universe.